Hello everyone. Today we'll be solving Leetcode number 69, which is square root of x. So for this problem, you're given a non-negative integer x, and you want to return the square root of x rounded down to the nearest integer. The return integer should be non-negative as well. And this is the crazy part. You must not use an inbuilt exponent function operator. Like, if you could do that, you would just do... Actually, I'll explain the problem first. So you're given x right here. Let's say x is 4, like the example. You return 2 because 4 to this 1/2 equal 2. Or in other words, 2 times 2 equals 4. So that's basically it. That's the math part of it. It's not so simple because you have to floor it, which means that you return. So let's say our answer we got 2.5 as the square root of a number. I don't know what number that would be, but let's just pretend. So 2.5. You don't return 2.5, you just return 2. It just rounds down, basically. There's another function called like top or something, at least in Python. I don't know what it is in Ruby. In Ruby it'd be floor. But yeah. That is the tricky part. Because you could just do like... I'm not sure. But you can just do easy. It's easy to do with inbuilt functions. So you just want the square root of a number, and then you want to leave the decimal point off. That is the 1 and 2. So 1 is square root, 2 is floor. And then if you can do that, you've solved the problem. There's sort of a trick to doing this that I'm going to show. I didn't make it up, but it's kind of a neat trick. It's kind of a hard problem, to be honest. But yeah. So now if you want to try to solve the problem after I've explained it, this is your opportunity to pause the video and go do the problem. And I recommend you always do. So here is the actual problem. Here are my submissions. This is how I solved it initially, because I didn't read the entire problem. This is really easy. It's just what I said before with the inbuilt functions. It actually accepts it because I don't think they're checking for Ruby, just because I think they focus elsewhere. And then this one over here, this is the real version. This is actually how you do it. And I'm going to walk you through it too. So this part up here, actually I'm not showing my screen, let me change that. This is how I solved it initially. Math.square root of x.floor. Very easy in Ruby. It's also it's not a bang method, it's just a regular method. But you can't do that because they say you can't, and during the interview you can't, so that's the way it is. This is the other problem, or the other way to solve it, the real way to solve it. It's sort of a trick, like, I probably wouldn't have been able to make this up. It's sort of like a complicated math thing. Basically, if x equals 0 or x equals 1, obviously return x. This just makes it so it returns the right value if it's already like done, basically, if it's 0, 1. Then you make a while loop after you set a couple variables, and it's while result is less than x, do x plus 1 result equals this. So what this basically does is that it times this I by itself, and then if I is greater than the initial number, it stops the whole thing, and it just returns I minus 1. It also increments by 1 at a time, so it's sort of not efficient because it only increments 1 at a time, and there's probably a better way to do this where you could just calculate right off the bat, but this is like the one way of doing it. If anyone has a better solution, please put it in the comments below, and we'll look at some other people's submissions in a second. So yeah, that's basically it. It's sort of like a trick, and this is also floored because you're returning I is always integer. It's always 1 plus 1 plus 1 plus 1, and then it's just minus 1, which is like a math thing. Basically, for it to be the proper number, you have to subtract 1. Not really a good reason for that though. It's just the way it is. Not always math has like a reason why, or like an intuitive reason why the math works. It just works sometimes. I guess I'll submit it now. It's gonna work. Yeah, so it's sort of, it's not bad. Memories. You can see here how different the variables are. Like this was 1,000 milliseconds. This one's 211.7. But this is also, it beats 14%. The second time I ran it, it beats 30%. What's up with that? It's just the way the Leetcode executes the program. This is not the way you evaluate algorithms, by the way. That's like the wrong way of doing it. You're supposed to evaluate by the big O. But Leetcode evaluates it by the actual runtime, which is like retarded. I understand why I do it that way, because it's just like more efficient. You don't put as much code in, but it's not like a... It's not the proper way of evaluating algorithms. Now we're going to look at the big O of the program. So you loop through it 1. It's basically just n. O of n, I think. Because actually it's more than O of n because n is 1 and it does multiple loops for each one. If anyone else in the comments has a better... It might be like... It might be greater than O of n. Because you... No, I think it's O of n. Because as n gets bigger, technically n is the number of variables that are in the array, but it may be O of n. Because you're using a while loop, so it's more than O of 1. If it was O of 1, that means I could check it right away. I wouldn't have to do a loop, basically. Because I have to do a loop, it's greater than O of 1. I think it's O of 1. Or O of n. So that's how I would say it. Let's look at some other people's solutions. This guy says beat 100%. Might be true, he actually has a lot of credit. Oh, he just binary search. Yeah, he basically uses binary search. I don't know how he gets the variable though. Because usually binary search is based off an array. Oh, divide repeatedly, search range nav. But what is the search range? The whole, is it just x to 0? See his code. This is just a binary search. He does math out round. Guess he's allowed to. It's sort of weird. I guess he's setting the variables as he goes. Does he times it by something? How is he doing this? This is kind of weird code. Because typically binary search is based off an array. Like you'd have an array of numbers. I'll show that. Whoops. You'd have an array of numbers. As an example, it's gotta be ordered for binary search. And then you have a mid, a bottom, a top, and you like set the bottom and the top to change as you loop through. And then at the end you arrive at a value that's correct for your use case or your search. You can try to run this code. It's not Ruby though. Let's see if he's actually telling the truth. And he's lying. It's 20% better, 20% better. So, another liar, even though it's high score. That's all for today. Thank you for watching. Subscribe if you want to subscribe. And thank you for viewing.